Welcome back. This is tutorial 6A question 2. We're given this periodic sequence x of small letter n is equals to x of small letter n plus 10. So he repeats every 10 samples, and this is of course our periodic pulse function. Now the periodic pulse function is derived in our handout, chapter 6.2 handout. So now let's go to the handout and see. Remember, in the handout I've given you the DTFT of all these functions. You need to look at 6A first, which is the DTFT of an aperiodic pulse, and then you can look at the DTFS of this periodic pulse. At the end, this is the equation, but again, please be very careful. This pulse is centered at time 0, and this is the answer. But you'll notice that in this particular example, this pulse is delayed by, I think by 3 samples. So in that case, you realize that this part are the same, and we have introduced this property of time delay. To see the property, go to chapter 6.2.3. Go to 6.2.3.2, the properties of DTFS, see the time shift, and basically when we have x of n, we'll get the coefficients a of k, but x of n minus n naught, we basically have each of these coefficients multiplying by e minus jk 2 pi over n times n naught. Now remember this, and now let's go and see our answer again. Because we are delaying by 2 samples, so this is the equation e minus jk 2 pi over 10, where 10 is n, and now it reduces to 2 pi over 5. So basically, this ck's coefficient is exactly what we have found in our handout 6.2, and it is 1 over 10 multiplied by this. But because this pulse is delayed by 2 samples onto the right hand side, therefore we need to introduce this exponential here for phase delay. For the detailed working, you can work this out by yourself by hand, and then of course then what you do is that you substitute for k equals to 0 to 9, and then you can get all these values of magnitude, and then of course the corresponding phase for ck's. I've written my MATLAB implementation here, and then you can see now that this is C0, C1 until C9 for the magnitude, as well as the phase for C0, C1 until C9, and the horizontal axis is K. And now let's compare. This is the answer, C0 0.5, this is C1, then C2 goes to 0, voila, and then C3 goes up a little bit, and so on and so forth. So this is both the magnitude and the phase. Well, this diagram only shows you the magnitude. This is a very typical questions on the pulse. Basically, you have to know how to derive the pulse that is centered, and from there we can ask various questions like this very easily. Thank you.